Hello everybody, this is the notes for section 1.4 for honors geometry. This is the first video that I'm asking you to watch for doing this idea of the flipped classroom and taking notes online at home or wherever you're at. So, some things to keep in mind. Just take notes like you normally would in class, but you have the advantage of a pause button. So, I'll remind you kind of as I go through some of these videos to hit pause at this time and either copy down the material or try the example, but use that pause button. It stops me from talking. It leaves the notes up on the screen so you can just copy them down into your notes, and then you can hit play again and you can start thinking about, okay, here's this stuff I can start paying attention to. Here's what Mr. Johnson's saying, and okay, now it kind of makes sense. All right, so section 1.4, measure and classify angles. First, we've got to define what an angle is. It consists of two different rays with the same endpoint. So, you've seen an angle before, you kind of know what it looks like, but proper definition says it's two rays. So, we have ray AC and we have ray AB. They are two different rays. They have the same endpoint. Remember, the endpoint of a ray is actually where the ray starts. So that's point A. In an angle, that is called a vertex. Okay, that common endpoint is the vertex of the angle. It's a very important point. The rays are the sides of the angle. Okay, so now, just like what we talked about with segments and lines and all this stuff, there's proper ways to name them. We are going to use this symbol. Okay, that is the angle symbol. Please do not do that one. As you start writing other names, it kind of gets confused, or it's easily confused with other letters like L or whatever. So you put this little arc in there. Okay, that's going to make it a distinct angle symbol. So when you name an angle, basically you're going around those two rays. But the key thing is the middle letter. That has to be the vertex. So angle CAB, as it is written here. Or go the other direction, angle BAC. Notice how we're just going around the angle, but the vertex is the middle letter. There is another way we can name angles with just the vertex point. So like it shows here, angle A. But you can only do that when there is just one angle at that vertex. All right. In this drawing, we have multiple angles at this one vertex. So you can't just say angle A because which one are you talking about? So if this was, not A. If this was point B and this was point C, point D, are you talking about angle BAC? Are you talking about angle BAD? Are you talking about angle CAD? If you just say angle A, you don't really know. But with the three letters, it is now specific. I'm going around these three letters, it's that one angle. All right, there are some different types of angles. You've heard of most of these names before. So go ahead, hit pause, copy these things down. All right, for an acute angle, that's most angles. An acute angle, it's basically between 0 and 90 degrees. We usually just say it's less than 90 degrees. We don't often talk about a negative degree angle, so it's just less than 90 degrees. If it's equal to 90 degrees, now we're dealing with a right angle. And notice this notation in the picture. You got this little like square kind of figure at that vertex. Okay, that's the notation that says this is a right angle. You go past 90 degrees, now you're talking about the obtuse. There's no real symbol to it, you just call it an obtuse angle, but that's more than 90 but less than 180. And this last name, it's a term, but we very rarely use it. Okay, a straight angle, it's a line. Okay, so key thing here is though, at a line, it equals a 180 degree angle. So it kind of comes into play with some of these terms that we'll get to eventually, but it's a line. We never say straight angle, but it does have an angle of 180 degrees. All right. Using a protractor. I hope by now all of you have used a protractor before. So just to kind of go through and also working on the names, I'd like you to hit pause and use this protractor to try to figure out the measurement for each of those angles. Let's go ahead, hit pause. All right, I hope you got them. So angle DEC, we are looking at D going to E up to C. So from 180 degrees over to 90 degrees, that's a difference of 90 degrees. Basically just taking the difference between those two measurements of where the rays are crossing the protractor. Angle DEA. So angle D to E to A. That's basically a straight line. That's 180 degrees. Okay, again, straight angle, but it's really just a line. Angle CEB. Let me clean up some of these lines here. Angle CEB. So from C to E up to B, that angle. So we're at 70 degrees here to 90 degrees here. The difference is 20 degrees. Now, when we say degrees, that's a unit of measurement for angles. So we're going to put 20, but then we're just going to put a little circle. Sometimes it's an open circle, just like you would see with the temperature. Okay, you know, it's right now it's 100 degrees out. It's Tuesday and it's pretty warm. So we just use that little symbol for degrees. Make sure you put that every time you're saying this angle is a certain number of degrees. And the last one, angle DEB. Change the color here. Going from D to point E at the vertex up to angle B. Well, this was 90, and then another 20, we're looking at 110 degrees. All right. Question is, how many angles are in the drawing? Well, very closely, or just very casually, you can just see those two angles, but there's actually more than that. You have this angle here in blue. You have this other smaller angle here in green, but you also have the largest angle. So there are three angles in this picture. To name them, again, the vertex has to be the middle letter. So angle in red, we had WXZ. In green, we had angle going from point Y around to X to Z, so YXZ. You could also name it ZXY. That order doesn't matter as long as the middle letter is the vertex. And the blue angle was angle WXY. Okay, three angles there. Again, go ahead and hit pause. You don't need to copy all this stuff down, but you do need the name, the angle addition postulate. I think this is a shorter and more precise definition, as long as you also put the picture into it. Okay? So, take a minute here, copy that stuff down. All right, so what I would like you to do is just try this example in your notes. What we'll do is, first thing in class, we'll do this example. We'll go over it, but I want you to try it on your own, see if you can come up with an answer. All right, last topic to discuss is the idea of congruent angles. Very similar to what we talked about with the congruent segments. So, when we are talking about angle measurements, we have this notation. We're putting a lowercase m for the measurement of angle, and then whatever you want to name it, angle A. When we talk about a measurement, again, like on a couple slides ago, we're talking about it equals 40 degrees, or whatever number of degrees it is. Okay, so we can say angles are equal to each other if we know their numbers, if we know the degree measurement. We also have angles being congruent. So, same congruent symbol we talked about with segments, but angle A is now congruent to angle B. We don't really know their measurements, but we know those two angles are the same. Now, the key thing here is in this picture on the left side of the screen. In pictures, to know angles are congruent, you are looking at that notation. It's just little arcs inside of the angle, right near the vertex. Sometimes it's just the one arc. Sometimes we put double arcs like this just to make them distinct from other sets of angles that may be congruent. All right, so that's the idea of congruent angles. The last term is this idea of an angle bisector. So we talked about a segment bisector. It was something that cut a segment in half. Well, an angle bisector is something that cuts an angle in half. Usually it's another ray cutting the angle into two congruent angles, but this is the notation. You're seeing these, you're seeing these red congruent arcs near that vertex. So those two angles are congruent to each other, those two smaller angles. Angle ABD is congruent to angle DBC. Because those two smaller angles are congruent to each other, that makes ray BD a angle bisector. All right, that is the end of the notes. We'll see you in class to talk about that other example, this one down here. Okay, have a good night.